2.5 Solutions by substitutions. So the easiest one we learned is a 2.2. It's a separable. You can just separate variables in terms of x and in terms of y, connect to the dy and dx, and you can solve that. And then the second technique we learn is the linear using integrating factor. And then third technique is the exact. So you let all those variables in front of dx as a m and n in front of dy. And then if derivative of y for m, derivative of x for n, they are the same, then it is exact. You can go follow those steps. If the equation is not following any of those three different techniques that we learned, then you need to use this substitution. So the substitution will let x equals to vy or y equals to ux, and then using chain rule. So from here, we have dx equals the first derivative and second one, y dv, plus first second derivative v dy. And from here, if you use y equals to ux as a substitution, you have a dy equals first derivative, second one, plus first second derivative. You have to use either one. For problem 2.5.2, I did it in both ways. Please take a look at the YouTube video, see whether you can follow all of those. So now we're going to work on 2.5.12. And this is the initial condition problem. So now let's multiply dy for both sides. Then we have x squared plus 2y squared dx equals xy times dy. And we have
If y equals to ux, dy equals x du plus u dx, and or x equals vy, then dx equals y dv plus v dy.
So you can use either one. If we use y equals ux and then dy equals to x du plus u dv, then you need to multiply dy in here. However, if we use this dx, we need to dx multiply these two terms, and then we have two terms here times two terms. It's going to be a little bit more than using dy. Say we're going to use dy for this time. Then we have x squared plus 2y is what? Ux dx. X times y is what? Ux. And then dy. X du plus u dx. And we have x squared plus 2 ux x squared dx equals ux squared x du plus u dx. We need to collect dx terms together and du terms together. Before we do that, we can cancel x squared everywhere.
1 plus 2u squared dx equals xu du plus u squared dx. So now we're going to move this to the left-hand side and combining with the dx term. Then we have 1 plus 2u squared minus u squared dx equals xu du. Then we have 1 plus u squared dx equals xu du.
Gonna divide 1 plus u squared so that we collect the like terms together, and then divide x here. Then u over 1 plus u squared du to the right hand side, and then 1 over x dx. So now we're gonna take the integral for both sides. For the right hand side, I'm gonna let 1 plus u squared as p dp equals 2u du. Then u du equals 1 over 2 dp. So we can use this dp 1 over p times 1 over 2 dp. So that is 1 over 2 ln p. We have an ln x equals 1 over 2 ln p, which is 1 plus u squared plus c. We have a u equals y over x.
Let's put that in. Ln x equals 1 over 2 ln 1 plus y over x squared plus c. And we have ln x minus ln 1 plus y squared over x squared of 1 over c equals to power of 1 over 2 equals to c. Ln x minus ln x squared plus y squared square root of x squared plus y squared over x squared.
And then we can combine this ln together. Log functions, if this is the subtraction, it's going to be the division.
So we have ln x over square root of x squared plus y squared over x squared. Now we have ln,
We're going to put this x inside of the square root.
then x squared over x squared plus y squared over x squared. That is ln square root of to the power of 4 x squared plus y squared.
Then take natural number e so that we can cancel ln out. Now we're going to square both sides. X4 over x squared plus y squared equals to C2 now. And we have initial condition y negative 1 equals to 1. We need to substitute x as a negative 1, y as a 1, then x as a negative 1. 1 over 1 plus 1 equals to C2.